Oh. Okay, so go ahead. We have almost everybody. Okay, so what I want to do today, I want to give you guys some time to work on your skinny, and then you also have a review exercise activity in AP Classroom tonight. It looks kind of long because there are 45 questions on there, but there's Ben. All right, let me just hold on a second and we'll get Terrence tomorrow at 8 a.m. Okay, so it looks long because there's 45 questions, but a lot of them, almost all of the questions are which test you did. So it's not like you have to do a big calculation or anything like that, okay? All right, so, but before we do that, I just want to take a few minutes and go through the most missed questions from the quiz that you guys had before the break. Do we even remember that we had a quiz before the break?
No.
Okay, so just to review, right? Let's just review a little bit. So yesterday in class, we really talked about which inference procedure. We did that flow chart, which we pushed the worked out key to the flow chart on OneNote. So you'll see that if you need to reference it. But so the AP Classroom review that you're going to do tonight is mostly which test do we pick, which inference procedure. But since we did the linear regression inference before the break, and we've had several days since then, I just wanted to kind of review the conditions for inference because they are the most confusing part of linear regression inference. I would go out on a limb to say on the AP exam, there will be questions on least square regression inference. I would think that there would be more multiple choice questions than FRQ questions. And if there is an FRQ question, it probably will not have you do a complete hypothesis test or complete confidence interval because it takes too long, right? So it would be something about the conditions, like which one of the conditions is violated or not violated, or how does this justify that condition, that kind of thing. Or it might give you a question and say, okay, assume the conditions for inference are satisfied, and then have you go on to do the rest of it. That's just, I don't know for sure. That's just, I would guess that that's what would happen. But anyway, let's just review what the conditions are. So you remember we talked about, let me see that, okay. Okay, so one of the most confusing parts for regression inference when we're trying to find the slope of the least square regression line is just checking the conditions, right? So we have the most complicated conditions for this inference procedure compared to everything else. And so if you remember, we said that we can use that acronym LINER, right? L-I-N-E-R. And it kind of spells linear, but you got to do the liner to get the A kind of thing, which is kind of silly. But anyway, so L linear, we're basically just saying that the true relationship between our X and Y variable, the true population relationship, is linear. And so the best way we want to show that is what? Yeah, scatter plot. We're going to plot our data. We're going to show that the data from our sample that we've collected, or our experiment, the data that we're using to estimate the true population least square regression line, has a linear pattern. It's not a parabola. It's not exponential growth. It's not exponential decay or some other model that might work better. It looks like a line would best model our data. So to do that, to check that condition, we can plot our data and see that the scatter plot is linear. And then we can also look at our residual plot to be sure that the residual plot is scattered, that there's no apparent pattern. associated with that. I stands for independent. Independent, we're pretty good at checking those conditions, but basically we're just saying our coordinate pair, so each X and Y combination is independent from another X and Y coordinate pair combination. And so that independent condition works like we have had in all of the other inference procedures. All right, so normal's a little different, right? Yeah, so what are we saying is normal? Right, we are saying that for each value of X, so for each value of X, so we have 3 little X values here, right? So for each value of X, the Y variable is going to vary normally about the regression line. So the distribution of our Y values will vary according to a normal distribution for each value of X. So how do we check that? Well, there's a couple different ways to check it. This is where we can plot a histogram of the residuals. We want to check that histogram and make sure that it's single-peaked, bell-shaped, symmetrical. From our sample data, it's never going to be exactly normal, especially if we have a small set of observations, which we do often in a least square regression inference problem. A lot of times with least square regression inference, we'll have a small set of data just because it takes so long to do these problems. So our histogram of the residuals is not going to be exactly normal ever. We can also look at the normal probability plot of the residuals. That would work, right? So we just really, on these problems, you just want to say that we don't have any reason to doubt that the distribution of Y variables for each X is approximately normal. So, okay, and then E stands for equal variance. So we could look at our distribution of residuals in our histogram, but really we want to look at a residual plot. We want to look at the residual plot and say the distance above and below the line where the residuals are equal to 0. So that would be our LSRL equation line. The vertical distance above and below that line on our residual plot is fairly evenly distributed. So we have equal dots above and below the line. And we'll look at one of the questions on the quiz that we had where that condition is violated. Again, this is a really hard one to check. You just, for purposes of doing an FRQ on regression, I would say assume the conditions met unless you read ahead later in the problem and it says, okay, which one of these conditions was violated? And then you know that you're supposed to look for some kind of feature about your residual plot that stands out to show you that that condition was not met. Otherwise, we just don't have enough data to show that for sure. So, and then of course R. So liner, R is random. So random, that's going to come from your prompt. And in the prompt, it will tell us that we have a well-designed random sample or a randomized assignment of treatments in an experiment. Okay, so let's look at some of the most missed quiz questions. Zoom in a little bit. So what I did, you guys can go back into your quiz and see exactly what you put and what you missed and what the correct answers are. But I just went through and I picked the, I put these in order of the questions that were most missed. So the most missed question was number 8, right? So let's just go through all of these. A reporter was interested in the relationship between the size of a dining party and the amount of time it takes to for the dining party to be seated at a restaurant. So they select a random sample of dining parties from a certain region. The resulting data were used to complete a linear regression analysis of time in minutes it takes for the dining party to be seated versus the number of people in the dining party. The linear regression analysis produced this residual plot. All right, so what do you see about this residual plot? You see that shape, that pattern there? Yeah, so based on this, it's saying which one does not appear to be satisfied. So first of all, we need to know what the conditions for inference are, right? And then which one of those is violated in this. And so the standard deviation of the distribution of time to be seated is the same for each size of the dining party. So that's just the equal variance of the y's, because it's varying much more for larger values of x than it is for smaller values of x above and below the line. Okay, you see that? So I'm not sure what the most missed wrong answer was. I don't know that there really was one. But I think part of the question, let's see, the way it's worded also, let's see. Oops, goodness. Say it again. E was, you think? Sorry.
Yeah,
This,
that was the one
bless you.
I like having them. That's
I think the other key is we're saying based on the residual plot. So some people may have said it wasn't necessarily, we don't know if it's a random sample, that kind of thing, but you want to use whatever the residual plot is being used for. Okay, then the next one that was most missed also has to do with residual plots. And on this one, it's saying which of the following residual plots provides evidence the condition that there's a linear relationship between weight and market price has not been met. So this is asking about there's a linear relationship. So the answer is A. Do you see why? Okay, what do these residual plots say, basically? What would B say? I know you would probably think, oh, you need to do zoom stat on the calculator, right? But what is B really telling you? Yeah, that's exactly right. All of the points on your scatter plot are directly on a line. Like there is a perfect linear relationship. Well, if we rig the data, it could be, I guess. Or if you had something like the cost of pizza toppings and it goes up by the same amount per pizza topping, that kind of thing. But so the one of the residual plot here that shows the most distinct pattern would be A. And that's what's giving you evidence that the linear relationship has not been met. Do we see that? Okay. All right. And I just picked, I think, five most missed questions here. All right, so on this one, I'll give you a second to just read it. And basically, so they're giving you the confidence interval here. And then you're asked to interpret the confidence interval. So they all look a lot alike, right? All the answer choices. So C is the correct one. Well, what does C have that the other ones don't have? And increases by 1 degree. Like, where do we get that? That's the definition of slope, right? That's what you're interpreting with your interval. You're doing a confidence interval for the slope. Think about the definition of slope. It's the change in y for every change in one x, right? Right? So I know that there's like, especially if you're pressed for time, there's lots of words that are really, really close, but you always want to look for average increase. And then, are there any questions about any of the other ones, why they're not right? Okay. What? Let's see, 11. I think it was 13. 13. Get my little sheet here. Yeah, then 13 was the fourth most missed question. So 13, again, they're giving you the interval here. So they're saying which of the following claims is supported by the interval? Okay, so why is E the right answer? We can't determine whether the linear relationship between player height and the number of points is positive or negative. How come, why is that? Is that true? What's in the interval? Zero is in the interval, right? So if you were using your confidence interval and doing a hypothesis test, if you kind of think about it in that sort of way, you would end up failing to reject your null hypothesis that there is no relationship because the slope could be zero in this case. Any questions on why the other ones are not right? Okay, yeah, question? No. Okay, and then the last one I was going to do is number 9. And then if you have other questions, I'm happy to look at those too. I just may need to pull them up. Okay, so for this one, I have no idea. Why did we miss this?
I missed all the questions that aren't in the-
What? This is supposed to be easy peasy.
No, I got this. I said it was all the questions that aren't in this.
Oh, okay. Well, you're unique. That's good.
Yep.
Okay, what are the correct hypotheses for this test? So let's don't even read the prompt and let's eliminate some of these possible choices here.
Let's eliminate
Okay,
C.
can we eliminate, first of all, why is A wrong? Yeah, this is a sample statistic, right? So little b is the sample slope. Okay, so it will never be little b. Think about, this is like using X bar or P hat in your hypothesis test. You can't use little b. So don't do A. Okay, so B, C, and E, without reading the prompt, those are all things that could work, right? Because the notation is at least correct. We have an equal sign in the null hypothesis. D can't work because you can't do it that way. You have to have equals in your null hypothesis, right? Not the inequality. Okay, so now we have a 1/3 chance of guessing. Okay, so why is it E? We don't care if it's a positive relationship or a negative relationship, just is there a relationship? Okay, so if you're just looking for some relationship, some linear relationship, not just any relationship, but some linear relationship, we need to use the not equals on the alternative. Okay. So those are the only ones I was going to go over together, but do we have any other questions? If you've looked at what you missed. And if not, if you haven't had a chance to look through them, that's okay too. You can look through it. You can do your AP classroom review activity. And then while you're there, look over your quiz and what you missed. And then tomorrow in class, we'll have kind of a review day. And I have a practice test, and we'll get that posted on OneNote. But tomorrow we were just going to do some practice questions, practice tests. So if you have any questions that I didn't answer today, just bring them on tomorrow and we'll go over them tomorrow. Yeah, question.
When you're checking the histogram of residuals for linear regression inference, does it have to be normal, or does it just have to be like unimodal, symmetric, etc.?
You just want it to be unimodal, pretty bell-shaped, like in a small sample size. You might even have some gaps in there depending on what, like how you graph your histogram, right? Because think about it, in your calculator, you could change the window settings and all of a sudden your histogram looks different.
So it doesn't necessarily have to be bell-shaped.
Ideally, it should be unimodal, symmetric, and bell-shaped. But if you're actually doing it, it kind of depends on how the question's asked. So if you're doing an FRQ and you only have 10 observations, say, your histogram is not going to be even close to approximately normal. For those, the equal variance and the normal condition, you just want to see if there's anything glaringly obvious that would give you reason to doubt that condition. And the way they would ask that would be really similar to like this, right? Like this one, where they said, which one of the conditions is violated?
All right.
Does that make sense? So it's almost like you kind of, if you're doing an FRQ, you almost want to assume that those conditions are going to be satisfied, unless you were to read ahead and see that on the next question, it says, which one was violated? Which condition was not met? And then you would kind of nitpick it, but otherwise just kind of, we don't have reason to doubt that this condition is met,
All right.
that kind of thing. Okay.
Okay, yeah, we have actually, there's one other quiz question that I meant to discuss here too. It's number 6. I'm not really sure why we missed this one. When you're given the computer output, these questions should be really easy to answer. And so we're using our computer output with our sample statistics for slope and y-intercept, and using that to create our confidence interval for the slope, for the 95% confidence level. So I'm not sure why we missed this question, but from the computer output here, we have the standard error coefficient. That's the standard error of the slope. So that is going to go right here. So the only other place I have that same number are these two. So we can automatically cross off that one and that one. Okay, and then the sample slope, 0.04625, that is going to be our statistic. So we have that in all of them. So the only thing that's varying in the options for option A, C, and E is the T star, the critical T that we need to use for the regression. So remember that for degrees of freedom, you need to do, it's for linear regression, it's n minus 2. So our degrees of freedom here would be 14. 16 minus 2, 14. And then you can do inverse T on your calculator, or you could look it up in the table if you want. Just remember, if you're doing inverse T, I don't believe that any of the calculators give you the option to do the center of your distribution. So when you do inverse T in your calculator, remember that you need to adjust the 95% level, right? So you have your T distribution kind of looks like normal distribution, right? So you have 95 here in the middle. And so that gives us 2.5% on either side. So when you do your inverse t, you're going to want to use 0.025, right, as your area, comma, and then your degrees of freedom, which is 14. So you'll do inverse t with that.